Hello my dear students, welcome to Biology at Priyojit. Today we are going to understand enzyme kinetics in easy approach in step-by-step manner. That is how fast an enzyme works and how substrate concentration affects the rate of reaction of an enzyme catalyzed reaction. So we will derive the famous Michaelis-Menten equation in easy step-by-step manner. Step 1, that is the basic enzyme reaction. First look at the top of the this diagram. That is is the enzyme, S is substrate, Es is the enzyme substrate complex and P is the product. K1 here is the rate constant for Es formation and K minus 1 is the rate constant for Es dissociation or breakdown, and K2 is the rate constant for product formation. So the first reaction shows that enzyme first binds to substrate to form Es, which then breaks down to release its product. Step 2 is the initial velocity. Now my dear students, we focus on initial velocity denoted as V0. So we know that V0 is equal to K2 into Es. At the beginning of this enzyme catalyzed reaction, product concentration is almost 0 and backward reaction here is negligible. So rate totally depends only on Es concentration. Now on step 3, which is total enzyme concept. Total enzyme is constant, so we can say that Et is equal to, Et means total enzyme, Et is equal to E, that is free enzyme, and plus Es, that is bound with the substrate. So E can be stated as Et minus Es. So this substitution is very much crucial for this mathematical derivation, Michaelis-Menten equation derivation. Step 4 is the rate of Es formation. We know that rate of Es formation depends on free enzymes and substrate. That is, rate of formation of Es is equal to K1 into Et minus Es into S. Step 5, that is rate of Es breakdown. Es breaks down in two ways. We know that back to E plus S, that depends on K minus 1 into S, that is E plus S will indicate K minus 1 into Es, and forward to product, that is K2 into Es. So rate of breakdown is equal to Es, breakdown of Es is equal to K minus 1 into Es plus K2 into Es. Step 6, that is steady state assumption. As stated, steady state, we have the rate of Es formation will be equal to the rate of Es breakdown. We know that is K1 into Et minus Es into S will be equal to K minus 1 into Es plus K2 into Es. So this is the core assumption of Michaelis-Menten kinetics. So rearrangement, after rearranging the concept, that is Es is equal to Et into S by K minus 1 plus K2 by K1 plus S. So Michaelis-Menten constant, we can assume, we can define a new constant as Michaelis-Menten constant, or Km, and we assume that Km is equal to K minus 1 plus K2 by K1. So the equation becomes Es is equal to E2 into Et into S by Km plus S. Here Km indicates the enzyme substrate affinity. We know that lower Km is the high affinity for the enzyme to the substrate, and high Km indicates the lower affinity of the enzyme and substrate. So step 9, that is substituting into into V0 equation. We know that, recall, V0 is equal to K2 into S. So substituting Es, V0 is equal to K2 into Et into S by Km plus S. So maximum velocity, when all enzyme molecules are saturated with the substrate, then Vmax will be K2 into Et. So the final Michaelis-Menten equation is V0 is equal to Vmax into S by Km plus S. This is the final Michaelis-Menten equation. So what is the key messages for my dear students? Enzyme kinetics explains the reaction rate of an enzyme catalyzed reaction. V0 always depends on substrate concentration. Km reflects the enzyme affinity with the substrate, and Vmax occurs when enzyme is fully saturated. So keep revising again and again. Stay curious and let enzymes reveal the chemistry of life to you. Thank you, my dear students. See you in the next class.